All right, guys, we are going to be looking at how to work these equations. So I've taught y'all the equations, you know them, and then you have homework that is on the math using these equations. But I want to make sure that you can work these math problems because we have a quiz coming up on this. So the first equation that we learned dealt with the speed of light, which is c. And you will need to memorize the speed of light. You need to know that it's 3.0 times 10 to the 8th meters per second. The speed of light is equal to the wavelength of light times the frequency of that light. Now remember that wavelength needs to be measured in meters. So if it's in nanometers, you need to convert it to meters. We also learned the Planck's constant equation right here, where energy is equal to Planck's constant times frequency. Now, you do not need to memorize Planck's constant. That is going to be given to you. But it's 6.626 times 10 to the negative 34 joules per second. So joules is the unit for energy. So anytime you write energy, you're going to be writing it in joules. And then we recently learned about Beer's law. Beer's law is the relationship between absorption and concentration. So if you have a solution, if we have a cuvette, that's a cute cuvette, and we're passing light through it, we're measuring the amount of light that comes in versus the amount of light that comes out. So say this is our solution right here. It's going to absorb light based off of the concentration. As it absorbs light, we will see less light come out. So let's use a lighter brown. The amount of brown that comes out, or the amount of light that comes out, will be lowered. We are measuring the absorbance of that, which is A. So if we increase the concentration, we would be increasing the amount of solute. So let's make this darker to represent that the concentration increases. So as we increase the concentration, we're even going to have a lower amount of light coming out. So we are going to increase the amount that it absorbs. So the light coming out, this light right here, is going to be even less. So it's going to be even less because the solute inside our solution is absorbing the light. So less light is allowed to go out. So with all of that being said, we also, hold on one second. We also can change the cuvette. If we make this cuvette smaller, so if we change what we call the path length, we're also going to directly control the absorbance. So if we have a cuvette that's, let's do, I think we were here. If we have a cuvette that's shorter or a path length that is lower, the absorbance is going to change with that. So let's put our light in. Let's put our solution inside our cuvette. The amount of light that comes out will be affected by the path length. So if you lower the L, you are also going to lower the absorbance. Okay, so let's look at the equation for that. Absorbance is equal to molar absorptivity. This is the one that I think y'all are getting messed up on. You either have to find E, and you just do algebra. I'll teach you that in just a little bit. Or you're given E. This is something that changes for every solution, every solute. Like if I change from potassium chromate to potassium dichromate, the molar absorptivity will be different. B is the path length. I have also written this as L before, so please don't be confused when I write L. It's the same thing as B. They're interchangeable. And then C is the concentration. And I said, don't worry about the units. I'm not concerned about you learning those because we don't understand what they mean quite yet. All right, so let's work on some of this. I don't want to take the C with me. Let's work on this problem. So the question says, what is E, what is energy, if the frequency is equal to 3.2 times 10 to the 6 hertz? So anytime you have a question, I want you to go back up to your equations and look at which one has the variables that you need. Well, I need E and I need V. This one has both. So I'm going to use that equation. E equals Planck's constant times frequency. For this one, it's pretty easy. You know Planck's constant. It's 6.626 times 10 to the negative 34. And you know what V equals. It's 3.2 times 10 to the 6. Multiply that out and you get an answer, and you'll put hertz with it because that's the unit for frequency. Not too hard. All right, let's look at this one. What is the frequency of the light if it has an energy of 3.4 times 10 to the negative 12 joules? So again, we have E equals 3.46 times 10 to the negative 12 joules. We want to find frequency, which is V. Well, which equation has E and V? It's the same one again. So let's look at this equation. E equals H times V. There's two different ways that you can do this, so I'm going to show you both ways. You can just plug in the numbers. Just go ahead and plug in 3.46 times 10 to the negative 12 equals 6.626 times 10 to the negative 34, which is H times V. And then you can do algebra and say, I want V. I'm solving for V, so I want V by itself. Well, what's in the way of it being by itself? It has this whole big number being multiplied by it. So algebra tells me that I do the opposite of what's happening. Well, it's being multiplied. The opposite of multiplying is dividing. So I'm going to divide both sides by 6.626 times 10 to the negative 34. Both sides. Okay. This side cancels because something over itself is just 1, and your V comes down. On the left side, you would do the math and solve it and get something hertz. So you just put this in your calculator and get whatever number that gives you. Now, the other way is when we adjust the variables itself instead of putting the numbers in first. It's the same concept, like we're doing the same thing. E equals HV, but we're going to rearrange before we put the numbers in. So again, I still want V by itself. Well, again, whatever is next to V has to go away. Well, it's being multiplied by V. So the opposite of multiplying is division. So I divide both sides by H. H over H cancels, and I have V. And then that means that V is equal to the energy divided by Planck's constant. Then you can put your numbers in. 3.46 times 10 to the negative 12 divided by 6.626 times 10 to the negative 34. This equals V. You put it in your calculator, you get a number. That's your velocity. That's your frequency. These numbers will be identical because no matter which way we do it, it's the same. All right, another problem. Let's use blue. What is the frequency of a light with 320 nanometers? All right, what is nanometers? It's a meter. It's a type of meter, which, I don't know why I wrote that, which is a measurement of distance. Which one of these is a measurement of distance? Wavelength. So, sorry, that looked weird. So what this is telling me is that lambda is equal to 320 nanometers. A big red flag should show up for you because we don't want it in nanometers. I told you up here that we want it in meters only. So this is where we need to convert. So I'm going to go down here and convert 320 nanometers to meters. Okay? The conversion of nanometers to meters is that 1 meter is equal to 10 to the 9th nanometers. Remember that anything that is equal, you can just write as a fraction. Just make sure that you keep the numbers with the right units. Like you don't want to write 10 to the 9th meters equals 1 nanometers because that's not true. So you can write this either way, And then the way that I told you to do this is to start with your given, which is 320 nanometers. Multiply it by one of these, the conversion that gets rid of your given. Well, it's on top. I want it to be on bottom so I can get rid of it. So I'm going to use this one, not the one with meters on the bottom. So I'm going to say 10 to the 9th nanometers is equal to 1 meter. That way that nanometers over nanometers cancels, and I'm left with just meters, which again was my goal. So if I do the math, I say 320 times 1 divided by 10 to the 9th. So really, it's just 320 divided by 10 to the 9th, which is 3.2 times 10 to the negative 7. All right, that seems like a lot of work, but once you learn this process right here, it's going to be really quick for you to go back and forth between nanometers and meters and whatever conversion that you want. Now that we know what lambda is in meters, we're good to go. So we can say that lambda is 3.2 times 10 to the negative 7th meters. Okay, you see how I use this right here, up here? All right, let's go back. Okay, so now that we have lambda, we know lambda, we want frequency. Remember, right here? So which equation gives us lambda and frequency? Well, here's one, lambda, frequency. So we can use this equation to solve for frequency, Okay, so the equation is C equals lambda times V. I want to solve for V. Well, that means I need to divide, since it's multiplied, I need to divide both sides by the lambda. Lambda over lambda crosses out, and I get just V. And then V is equal to the speed of light divided by the wavelength. So then I can just put those numbers in. 3.0 times 10 to the 8th, that's the speed of light, over the wavelength, which is 3.2 times 10 to the negative 7. That equals V. You do the math, you get the answer, it's in hertz. Okay, the last thing that we discussed was Beer's law, which was A equals EBC, where all of these are being multiplied together. I told you that we could solve for E, which means we want to get E by itself. The same way that we did the others, we're just going to follow our rules of algebra. I want E to be by itself. Well, currently is being multiplied by B and by C. The opposite of multiplying is dividing. So we're going to divide both sides by B. We're also going to divide both sides by C. So you can do that at one time. You're dividing it both by B and C. If you don't like that little raised dot, you don't have to put it. You can just put B and C. And then you know that epsilon, or E, molar absorptivity, is equal to A divided by B times C. So if we had numbers for this, if we had A equals 0.45, C equals 3.2, and B equals 0.5, you can put all of those numbers in. You can say 4.45 divided by 0.5 times 3.2, and you would get your molar absorptivity. All right, if you have questions, email me. Remember, my email is car160 at this stuff. Just let me know if you have any questions. Come to me in class if you have questions. Review over this, practice it. This should apply to your homework and your quiz that's coming up.